Hello students, I am Dr. Achin Srivastava, Associate Professor, SkyT Jaipur. Today we are going to learn about how to determine the binomial probability. So what is a binomial probability? Binomial probability refers to the probability of exactly X successes on n repeated trials in an experiment which has two possible outcomes. For determining the binomial probability, we have conducted an experiment in quality control lab. We have taken a box containing 100 balls, out of which 70 are white balls representing good products and 30 red balls which represents defective product. An experiment is performed with drawing 10 balls at one instance and has been performed 20 times. The observations that are obtained with these experiments are documented in this table. We have seen how many red balls we have obtained because red determines the defective. So similarly, this experiment has been repeated 20 times. So again, we have mixed the balls and again picked the another 10 balls, and this is the observation table for it. Now let's see how exactly we are going to determine the binomial probability. So for finding it, first we will see first we have to count the defectives, red balls that has obtained in each trial. Make use of the function countif. Now to select the range, here we have to mention red because this is a defective ball. This we want to determine how many number of defective balls. So it comes to, if I drag the formula down, so this is the number of the defective balls in the first sample. Then the second time again we have drawn. So in the second trial we obtained 5 defective balls. In the third trial 3. Likewise we have obtained the defectives percent. Now first we have to find the experimental probability, because what is the probability that we obtain with this experiment. So for having the defective X, suppose there is 0 defective, 1 defective, so I can just drag it down. So there can be only the 10 defectives are possible. So what is the defective count for 0 defectives? So what we have to do, again I can make use of the formula countif range. So this is the number of balls, this is the number of the defects that has obtained in each trial. So I have selected it. Now I can select this one. So this will give the, so 0 is comes as 0, but since I have to drag it down, so I want to reference this column from where I am taking the count. We have to count the number of instances in which there will be 1 defective, 2 defective. So I just give dollar sign here, dollar sign here. Again here I am also put the dollar sign so that the values will remain unchanged. Now I can easily drag it down. This is not here up to this. So you can see here there is the how many instances where there is the exactly 1 defect. So you can see 1 has come as 2 times, so 2 defects, 2 defects, so 2 is come here 6 times. So this has just counted the defective count of exactly 0 defective 0 times, 1 defective 2 times. Now to determine the experimental probability, so it can be easily done. We have to select the defectives count. So how many times the exactly zero defective has come? Zero times. Divide by the number of trials that are fixed. I can drag it down. So this is the experimental probability I have obtained. This is the experimental probability here, zero. Formula for the binomial probability. So, so this is the probability of the binomial probability is calculated like this. So for the x, but for the x instance, or the you can say the when the probability for the zero defective when x value is 0 or 1. So by putting this we can make use of it, and since the number of trials, and p is the probability of finding the defect or probability of success, q is the probability of the uh, failure. So naturally q can be computed by the p only, so it is q will be equal to 1 minus p. For determining the mean, we can make use of the formula mu equal to n into p. N is the number of trials, p is the probability. For determining the standard deviation, we have to take the square root of the product of the mean into the q, so that to determine the theoretical probability. So we know the n in our experiment, because we have conducted this experiment 20 times, is 20. P, probability P is 0.3, because in a box where we have taken 30 red balls which are defective out of the 100. So 30 upon 100, this gives the 0.3. So the value of the mean, so this can be easily be computed. It can be 20 into 0.3. So this is the, I can say, the value of the mean, and into the p, and this is the same for all the instances. So this is the mean value. Now if I want to find the x, how many defects are there? Is it 0, 1, 2? So up to, so there can be 10 possible defects, because we are drawing the ball 10 times. So I just determine it. Okay, now the theoretical probability for it can be calculated. Now likewise this is also 6. So here the values, again if I want to calculate it, so this will be the same as here. It is the product of this. So I just, what I do, I take the reference so that it will not changed. Again take the reference in the formula, just this. Now I can easily drag it down. So this is the mean. Now for finding the theoretical probability, I am making use of the function Poisson distribution. I'm making the function Poisson distribution. What is the x? X is here. What is the mean value? Mean is selected here. After selecting the mean, what we have to need is cumulative. No, it's probability mass function values we are computing. So just have to write false. Again, now I just click this. So this is the theoretical probability for the 0. I drag it down. Now we have determined the probability for the theoretical probability for when x equal to 0 defect, 1 defect, 2 defect, up to 10. So now after getting the experimental probability and theoretical probability, we can plot the first we are going to plot the experimental probability. So how we are going to plot it? Go to the insert, just select this, control experimental probability, go to the all charts, we can see the figure here. This is the experimental probability. Here I can give the add the axis titles. This is X, that is the defects that has been shown. Now I can just adjust it. Here I can give probability. So here is the experimental probability chart. Now for plotting the theoretical probability, I pick this. After selecting this, insert, charts, going to the charts. This is the picking it. This is the for the theoretical probability. This is X. This is the binomial probability. So in this way, we are going by conducting the experiment. We will first see the experimental probability and then compare it with the whatever the binomial probability. So thank you for listening.